I'm not going to use projections. I'm going to try to scare you a bit, because I don't think that many people really get it as far as how difficult a problem this is. This is an awesome problem. And you know, we have people who don't want to believe it at all, but a lot of people who are aware and accept that it is a problem don't really get it as to how serious a problem it is. It's really, really bad. And all you young people here are going to spend decades involved in watching what happens. And so I'm going to try to lay it out, what you're facing. You all know that, most of you know that we're burning an enormous amount of CO2 every year. And despite the fact that we realize that we should be cutting back, in 1990 we produced 20 billion tons of CO2. Last year we produced about 32. So between 1990 and now, when the Kyoto Accord was in effect, rather than going down, there was a steep rise in fossil fuels. Estimates are that with population growing about 1% a year and GDP for the world going up at 3%, that we could have a 4% rise for the indefinite future. We know that the discovery of the ability to frack to get oil and natural gas has really ensured that we have enough fossil fuels for a very long time. And I bought gas last week, and I've been paying, you know, $3.50, $3.70. It was $2.94. So right at a time when we need to have higher prices on fossil fuels, the abundance of energy is driving the price down, making it ever harder for the kind of thing we have to do, namely get our energy from renewable sources. Everybody agrees on that, but we aren't doing anything to speak of. When I first got interested in this, back, well, you could say 75, we were getting 15% of our energy from non-fossil fuel sources, getting 85% from fossil fuel sources. Today, it may be 84 and 16, but we haven't really started to cut back. And if we want to stop CO2 from rising, we have to cut back to less than 10% we're producing now. Otherwise, CO2 keeps going up. Of course, as we cut back, it'll go up ever more slowly. Right now, CO2, last May, Elizabeth, my wife, and I were at Scripps with Ralph Keeling, who took over for his father as the chief measurer of the rise in CO2. He told us that CO2 almost budged 400, but he said he couldn't announce that because it only got to, in Hawaii, to 398.8 or something, and it wasn't for the full day. But the next day it did go over 400. So that means that since turn of the last century, 1900, it's gone up from something like 280 up to 400. George Denton and I spend most of our time trying to understand paleoclimate. What George is going to tell you tomorrow is that we can make a very strong case that the ice ages were driven by CO2. And if so, that means a drop. And George, they've also shown that from glaciers at 40 north, mountain glaciers 40 north and 40 south, reached their maximum at the same time, which eliminates one of the primary ideas about what drives glaciation, namely orbital cycles. And they showed that the cooling at 40 north and 40 south in the glacial period was something like 6.5 degrees centigrade in the summer. So a drop of CO2 from 280 to 190 drove those glaciers out and changed the whole world. We've now gone from 280 up to 400, so we've actually made pretty much the same change in the other direction. And we're driving CO2 up at 2.5 parts per million a year. And if we continue this 3% increase in energy use on the planet, per capita energy use, and 1% increase in population, within 50 years we'll be up to 5 parts per million a year. Now, everybody that believes this is a problem says, yeah, we got to go to alternate energy sources. We got to turn the sun and go back to nuclear perhaps and use wind, maybe tides. There's certainly ways to do it, but think about it. To go to another energy source requires changing our entire energy infrastructure. Maybe not the power lines, but everything else. That's a huge, huge expenditure. It takes, even if we were ready to do it and knew how to do it, the changes in the past tell us that the market penetration time is about 40 years. So that's another 80 parts per million in 40 years if we didn't, increase over what we are now. So what we've done is we've painted ourselves into an incredible corner. Our options are to, sort of ease the situation. The outlook is just terrible because it's going to take a very, very long time to make the switch over. And the fact that, I became the godfather or whatever of global warming in 1975. By the way, that annoyed me to no end. So I held a contest and I said, can anybody that can find an earlier reference to global warming, I will pay you $200. And I had a postdoc at the time, David McGee, who's now a professor across the river at MIT. He found it. And it was a little clipping from a northern Indiana newspaper. It was about this long and no more than a couple hundred words that said two scientists, this is in 1959, so 16 years earlier than my paper. And he said two scientists in Southern California, unnamed, warn the world that industrial CO2 emissions may cause global warming. So those words were in the newspaper. And it was obvious to me, even though they weren't named, they were from Southern California, and that's the year that Charles David Keeling started his CO2 record at Hawaii. So he was obviously thinking about that. And he had died before that, because otherwise I would have tried to foist the title off on him. I paid David McGee $200, but I'm still, as George said, the godfather of global warming. I don't want that on my tombstone. I'm 83, so I've got to figure out how to dump that title. Okay, back on track. Oh, by the way, when I give this lecture, I like to get a lot of questions, and tough questions at the end, so I'll try to leave time. So what are our options? I mean, we could live with it, but there's a lot of the probability that what we have to live with is going to be unacceptable compared to what we have now is rather large. We may luck out and it'll be something that we can easily handle, but the median prediction is if we go from 280 up to 560, and we're already up to 400 and moving toward 560 in a time scale of 60 or 70 years, that the temperature will rise planet-wide 3.5 degrees. This is based largely on computer models that try to simulate the entire planet. Atmosphere, of course, oceans, ice, vegetation. And these are fallible because we don't know the physics of many things like raindrops, eddies in the ocean, things that turn out to be important, we have to parameterize. So what people decided to do was to take a given scenario of doubling CO2 and a given model and have 3,000 different people or different, it didn't have to be different people, but different computer runs that could be run on an ordinary PC, where all of these parameters that are non-physically set were varied across their entire reasonable range. And so they got 3,000 different answers. And the median was about 3.5 degrees, like the most modelers have been saying, but 15% were above 5 degrees. And they went all the way up to 11, which seems outrageously high. And none of them were less than 1 degree. So that means there is a range of uncertainty. It's asymmetric. There's more probability that it'll be greater than 3.5 degrees than less. And 3.5 degrees is going to really change things. I think water, which is becoming a big issue, is going to move around. We're going to get, some places are going to get a bonanza of rain and other places are going to get starved of rain. I think from our paleo records we know a lot about that. And more and more people are talking about the idea that the great West Antarctic ice sheet broke, a lot of it disappeared during the last interglacial, that sea level was up to 7 meters higher than now. I'm not quite ready to buy into that, but the people who are doing it are very good, and it certainly seems like it might have happened. And so if we do global warming, we're just asking for it. A collapse of that ice sheet is basically unstable. So that's coming back, and not that we'll have a catastrophe, but if we had a sea level rise in the next 500 years of several meters, that would really be expensive. It might not kill anybody, but it would be, we'd have to either give up land, valuable beachfront property, or we'd have to dike off. Like I read in the Times, they want to do to my city. They want to put a wall around Lower Manhattan. We have two options beyond this, and they would be sort of, what do we do if it's a bad CO2 trip? The one I'm most interested in is what they call negative emissions. That's capturing CO2 back from the atmosphere or from power plant smokestacks. I happen to think that it's a much better way to go about it would be to take it directly from the atmosphere. I have a man, a friend, Klaus Lochner, has been my friend, and I've talked to over the last 13 or 14 years about this, and it's been his main line of research. He happens to be the most brilliant person in my long career, where I've met a lot of prominent scientists and dealt with them. He's clearly the most brilliant mind that I have dealt with. He wants to do this, and he thinks it can be done for less than $100 a ton. Now that would be put an additive on gasoline of about $1 a gallon. So that's affordable. But there are others, including one of my least best friends over at Harvard, who say that it'll cost $600 a ton. That would be $6 a gallon. And there was a report written some years ago that said it would be $1,000 a ton, which would be equivalent of $10 a gallon on gasoline if you wanted to remove the CO2 produced, by burning 1 gallon of gasoline. I happen to believe, I know enough about it that I think Klaus's estimate is reasonable, and that it's very likely something we can do in an affordable manner. Okay, now let's just start to see the magnitude of what we'd have to do. If we were to take out the 32 billion tons of CO2 we produced last year, in other words, just clean up like we do garbage and sewage. We're not trying to lower the CO2, we're just trying to take out what we added last year. It would require 100 million of these units. You'd say we could never build 100 million units. Well, they would be about the size of and complexity of an automobile and probably have about that much material in them. They would be, one of the great advantages of them is that they would be employed in dry wastelands, because the material they use to capture the CO2 trades CO2 for water. So that it's a plastic with amines embedded in it that happens to contain water, and when you put it out in the atmosphere, CO2 kicks off the water and takes its place, and then you bring it into some device that you can get it wet again, and it gives off the CO2 and takes back its water. Our plants, the food we eat comes from plants that use about 500 molecules of water per molecule of CO2 they fix. This plastic, it's about 10. So it does, release water to the atmosphere, but a lot less than a plant would that was taking up CO2. Plus they could take up CO2 something like 100 times faster than a plant, because they're built to do that, and they don't have to make it into sugar and all these other things. That's interesting. I mean, what we build, something like, 40 or 50 million cars a year. We build 60 or 70 million containers a year. So we have the industrial capacity to build those things if we had the will and the money. So it's not impossible. It would mean that everybody that had a car should buy one of those things and donate it to the world. So they would be placed in dryland areas where there was low population, because they obviously would be an eyesore. 100 million of anything is an eyesore, where cars are an eyesore. And the CO2 that's captured would be liquefied, and the places you do this would be above geologic strata in which you could store the CO2. That would be either sandstones or basalt. And I think we know how to do that. It has a big advantage that if you take it out of power plants, you have to run high-pressure CO2 pipes under cities to get it far away where you could bury it. And then, since the population density in places like this is high, you have to think hard where the hell you would put it, that people wouldn't have big complaints that what if it all came back. So Lochner says another interesting thing. He said, number one, we should be doing it now, and we're not. The amount of money that's been spent on this so far is, I would say, no more than $40 million in 10 years. Nothing. A-Rod made that in 2 years with the Yankees and didn't even hit many home runs. You must have somebody like that in Boston. Papa? What is he? Pepe. Some big guy I know that hits home runs for the Red Sox. Anyway, there's been almost no money spent on this so far, and there's great resistance to doing it. And I maintain this is absolutely stupid, because we're not saying we're going to start pulling it out of the air. It's going to take 20 or 30 years of research to go from the Model A to the Toyota, just as it did with automobiles. If we're going to build 100 million of something, we better really know how to do it and how often we're going to have to replace it. We go to Arizona every winter, and I realize that if you put these things out in the desert, there's a whole armada of organisms that are going to want to get into it and mess it up one way or another. That all has to be thought through. They have to be field tested. But Lochner would say, number two, we're going to end up, before we get to utopia, which would be other sources of fuel, of energy, we're going to end up at 600 or 700 parts per million. I mean, that would be what I'm guessing. Of course, that's a guess. And if we're that high and it's quite a bit warmer, there may be a big desire to bring CO2 back down again. Well, CO2 will go down on its own, but it'll only go down because it's going into the ocean. And to get it into the deep ocean, which is the big storage bin, will take hundreds of years. So it'll only go down very, very slowly. And during that time, we could have a lot of ice cap melting, among other things. So he would say that if we did want to get rid of CO2, we could use the same units and take out more CO2 than we add and start going the other way. So let's say with the present fuel use of 32 billion tons, we wanted to not only go neutral, but to go negative and drive it down 2.5 ppm per year rather than up. We'd have to build another 100 million of them, so it would take 200 million. If we wanted to go down at 5, it would take 300 million. If we wanted to go down at 7.5, it would take 400 million. So it starts to get ridiculous. And so we may do that. We very likely will. But in an emergency, it doesn't solve the problem, because there's no way we could draw CO2 down fast enough. Because not only do we have to take out the CO2 we put in the atmosphere, but 25% of that, what we put in, has gone into the ocean, and we would just suck it back out again and have to bury that too. So now comes something I'm sure you're all going to see that I don't like, you're not going to like, but the world is forcing itself toward this. There is something else that we can do. And that is, we can change the reflectivity of the planet. And we know how to do that. I wrote a paper about it once. It was an idea that a Russian scientist named Bodiko had during the Cold War. And as you put SO2 in the stratosphere, it automatically converts to little aerosols of sulfuric acid. These aerosols backscatter 10% of the solar radiation that hits them. So to undo doubling of CO2 is equivalent to, doubling of CO2 is equivalent to dialing up the sun by 2%. And so if you want to balance it out by changing the reflectivity or albedo of the planet, you would have to have 2% of the sunlight that hits the top of our atmosphere, 2% more be bounced back into space. And since these aerosols only scatter 10%, that would mean that you'd have to have 20% of the atmosphere. Any solar ray coming in would have 2 chances in 10 of hitting one of these and 8 chances in 10 going right through. We've seen the visual effects of this from Pinatubo most recently in 1991. Makes beautiful sunsets, but it also is going to do a lot of other things. There's no guarantee if you did something like this that it would totally undo. It would be patchy. It would overdo in some places, underdo in others. It wouldn't bring rainfall back to where it was probably. But 2 things that are going to tempt the hell out of politicians. It's 10 times cheaper to do that, maybe 20 times cheaper than to build these units and operate them. So it's an El Cheapo solution. And also, you could, instead of having to wait 30 years to have an appreciable effect, you could get an appreciable effect in 6 years. So it's also much faster. And therefore, it's very tempting. Of course, it doesn't stop ocean acidification, because you'd be producing CO2 all the time. It would be a stopgap. It would be a dangerous one, because you have to have 32 million tons of SO2 go up every year, because these little aerosols are going to come back down from the stratosphere onto land and into the ocean. If we started this and had a war or something and stopped, of course the planet would heat back up again as fast as it cooled down. So it would be a shield that you have to keep there. And since it'd have to be replaced every couple of years. Okay, if I had a vote for that today, I'd vote a firm no. But you're going to be faced with a situation where possibly there are a lot of climate effects that have heavy impacts on our agricultural productivity, on sea level and so forth. And you may decide that we have to temporarily use this SO2 to cool off the planet. I had a college mate named John Knuckles. We didn't use the term nerd then, but he would have been the perfect nerd. He was a good friend of mine. We both were at Wheaton College in Illinois, and then we were at Columbia University. He disappeared, and he reappeared to me only 20 years later. He'd become chief assistant of Edward Teller, the big bomb man at Livermore. And so we got in touch, and he invited me out there, and we wrote a paper on this in 1986 about SO2 as a safeguard against a bad CO2 trip. And when the paper was done, I sent it around to Frank Press, who was head of the National Academy of Science, Bert Boleen, who in later years was the chief editor, chief writer for the IPCC reports, and a couple other people. And they wrote back firmly that the world was not ready for this, that we should not publish it. We should not even submit it for publication, and we didn't. We held it, and the only record is in the Daily Telegraph in London published a short thing about it, and really it would take 700 747s flying around the clock to get this SO2 up there. The sulfur would cost about $10 billion a year. This is 1985 dollars, but I was able to call up Freeport Sulfur and find out how much sulfur cost, SO2 costs, and the guy told me, he said, you want the whole world's production for 1 year, and I said, yeah, we need a lot. And I called up Boeing, and I said, you know, you've got to, can your plane, how much could these planes take if they had to fly another 10,000 feet higher? Because there's an, you know, ideal elevation you'd put this SO2 in. And they did all these calculations for me. So we had all the information, but we never published it, and I'm kind of glad we didn't. But about a decade later, a guy named Crutzen, a Nobel laureate, wrote an article about it, and so it's out of the box. And there are people like David Keith across the river who thinks we ought to start right away doing it. So it's something that is emerging, and it's going to require huge debate. You can't do a little of it and find out what its effect would be. You pretty much have to go the whole route and to find out, and probably have to do it for a decade. If you didn't like it, you could turn it off and it would go away. But you'd have to do a very large-scale decade experiment. And I don't think any country in the world would sort of dare to do that, because it would be a funny 10 years. And anything that bad happened would be blamed on SO2. So my message to you is that this is a very, very difficult, perplexing problem. And so far we're going nowhere. I mean, sure, solar energy is coming along slowly, wind energy, and nuclear may come back. But the rate at which we're doing things is minuscule compared to what we would have to do an effective job. So somehow we have to get with it. I actually think that it won't be done until the world realizes that it's a global, an enormously serious global problem, and they appoint something like the Fed. The Fed is supposedly here free of political manipulation. Maybe it isn't, but it's supposed to be. So I think there would have to be some kind of agency in the world that had lots of power with regard to regulating CO2 to ever get it done. Now, the probability of that happening and our Senate ever verifying anything like that, you know, isn't very large. But I think things are going to change, because we're going to start to see the impacts and realize that they can get really serious. So with that, I'll stop.